So on the next page of 2.1, more on derivatives, we have another example. And this example says, let f be the function which satisfies this property, this equation right here, for all real numbers x and y. And they even give you a hint here. They give you a fact. They give you the limit of f of h as the limit of as h approaches 0 of f of h over h is 2, and then it says use the definition of derivative to find f prime of x. So let me go ahead and recite the definition of derivative. The definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. And that is what we're trying to find right here. We're trying to find this. But we have a real wacky equation in the problem. Let me go ahead and rewrite this equation down here. Now if you notice that my equation has x's and y's, but I need to somehow use the derivative definition which contains an h. Oh, I messed up right here. So here I put plus h. It's supposed to be a plus y. Now I'm going to go ahead and make a statement here that's going to help me solve this problem. In mathematics, you have to think outside the box, and this is what I'm going to do. I'm going to go ahead and say that let h equal y. Alright, so rewriting this would be f of x plus h is equal to f of x minus 4 f of h plus 9xh. I pretty much said that let y be an h instead. And then now I can use my definition derivative. Notice I have an f of x plus h minus f of x. So I'm going to go ahead and subtract f of x to both sides of the equation. So I get f of x plus h minus f of x equals a negative 4 f of x, f of h plus 9xh. Now, in order for me to use the definition, I have to divide h to both sides. And not only do I have to divide h to both sides, but now I have to take the limit of both sides of the equation. The limit as h approaches 0. Now, this part that I'm about to highlight, you should know what this means already. This means the derivative. Notice, I have it right here. What is this highlighted part equal to? Well, it simply just equals to f prime of x, a derivative of f of x. So, f prime of x, this is this part down here. And then when I divide h to both sides of the equation, I can cross out this h, and I can separate the fraction so that I get negative 4 f of h over h, and then plus 9x, because an h divided by h removed the h from the 9x, but I couldn't do anything to the left side of the plus sign, so I'm going to leave it as is. Oh, and I forgot to write the limit as h approaches 0 of this whole function here. Alright, when I apply the limit, notice, if you notice my hint, this hint here told me that the limit as h approaches 0 of f of h over h is equal to 2. Well, I have it right here, except there's a 4 in the front, which is no biggie because we all know what that highlighted blue is now. That highlighted blue is a positive 2. So once I apply my limit, I get negative 4 times 2 plus 9x. 9x remains because there was no h. Anytime you take the limit of something and the variable is being dependent on like an h and there's no h in the function, you just leave the limit as is. The limit is just whatever you're taking of, and you get negative 8 plus 9x, and that is my f prime of x. That is my answer to this question here. On the last problem we have these types of problems are very common in the AP exam. Okay, they always like to ask you things. They're trying to test your calculus here. Okay, they're trying to test if you know what a derivative means, and not only what a derivative means, but if you know like your actual definitions. So here they're giving you a question that says, given the limit as x approaches 5 of this function, which is equal to 3, which of the following must be true, might be true, or can never be true? Well, what does this function represent? What does this limit represent? Recall the alternate form, the alternate definition of derivative. The alternate definition of derivative says that if I want to find the derivative at a certain x value, I can take the limit as h approaches as x approaches c of f of x minus f of c all over x minus c. And remember that this definition is supposed to give you a number. So it pretty much says if I take the derivative at 5, it equals 3. That's pretty much what it says. That's what this highlighted part says right there. You need to know your definition. Excuse me, that was my phone, sorry. You need to know your definition. So let's go ahead and check our answer choices. It says here, letter A, can this one be true, might be true, or never be true? Well, this one is obviously true, since it pretty much, it's given to you. Letter B, it says f prime of 5 can be 0. Well, that's not true because we already know what the derivative is at 5. It's 3, so it cannot be true. Never be true. Never. It says there f of 5 is equal to 3. Well, were we given information about the function? We weren't. We were given information about the derivative at 5, but we don't know anything about the function at 5. So we can say this might be true. We're not certain, but it could be true. There may be a coincidence in which the graph is 3 and the derivative at x equals 5 is also 3. Maybe a big coincidence, but we don't know that for sure. The function is continuous at x equals 0. Well, we don't even know what the graph looks like. All we know is that at x equals 5, the slope is 3. So this might be true. We don't know for sure. Okay, and letter E says f is continuous at x equals 5. Well, if we go back to the top page, or yesterday's, last video, I said that differentiability implies continuity. That means if the derivative exists, then the function must be continuous. So this one is always true. Or let me go with the question, must be true. That one must be true. That one must be true also. And then it says the limit as x approaches 5 of f of x is equal to f of 5. Well, just like we don't know anything about the function, okay, well, we do know for sure that the function is continuous, so it could be possible that the limit might equal f of 5, but we don't know for sure. If we knew more information about the function, we can say this must be true, this may never be true, but since we don't know anything about the function, this could be true. And that concludes today's video.